So let's talk about the story of AI, because it's not just a story about technology, right? It's really this epic centuries-long quest by us, by humanity, to understand the single most complex thing we've ever encountered, our own minds. And this quote from Sophocles, it absolutely nails it. This is the perfect place to start. Because long before we ever dreamed of computers, the whole idea of AI was really about trying to capture and recreate that very wonder, the wonder of us.
So yeah, our journey doesn't kick off in some garage in Silicon Valley. Nope, it starts way back in ancient Greece with philosophers who were the first to even try to map out how thinking works. Okay, let's dive in.
Way before a single line of code was ever written, the foundations for AI were being laid, and not by engineers, but by thinkers, philosophers, who were trying to figure out the basic rules of human thought itself. This is where Aristotle comes in. He gives us the first real blueprint for what you might call correct thinking. His whole system of syllogistic logic, it showed that reasoning could actually be broken down into a step-by-step, almost mechanical process. And that was the very first hint that maybe, just maybe, thinking is a kind of computation.
And that one idea, that thought is just a form of calculation, what kicked off this incredible centuries-long relay race. You had thinkers and inventors passing the baton from one generation to the next, all trying to turn that abstract idea of logic into actual physical machines.
And man, what a race it was. Just look at this timeline. You can almost see the baton being passed. We go from Leibniz's calculator, which was a huge first step, to Babbage's analytical engine. I mean, that thing was basically the blueprint for a modern computer. And then you get Boole's algebra, which gives us the binary logic that every single computer today still uses. Every step was just a crucial piece of the puzzle. But this is where the vision gets really, really big. Ada Lovelace, who worked with Babbage, she looked at these machines and saw something more than just a glorified calculator. She saw that they could be artists, that they could manipulate any kind of symbol to compose music, to create art. Think about that. She was describing generative AI back in 1843. It's just incredible. Okay, let's jump forward. We're in the 20th century now, and this is where all those abstract ideas and mechanical gears finally go electric. And one person, the brilliant Alan Turing, steps in and completely changes the question everyone was asking about AI. You see, Turing just cut right through all the philosophical arguments about whether a machine could truly think. He basically said, you know what, that's a dead end. We'll never agree. So instead, he proposed a simple, practical test. Can a machine act so intelligently that you can't tell it's a machine?
And the beauty of his test, the Turing test, is just how simple it is. It's not about consciousness or feelings or what's going on inside the machine's head. It's all about performance. If it can fool you, for all practical purposes, it's intelligent. And that simple idea shifted the entire focus of AI research for decades.
And that new performance-based focus set the stage for this moment right here, the summer of '56. A bunch of researchers get together at Dartmouth. They give this brand new field its official name, artificial intelligence, and a super bold mission. And that kicked off this amazing era of optimism and, frankly, wild creativity. But all that early optimism slammed headfirst into a wall of reality. Turns out, building an AI that can handle the messy, complicated real world was way, way harder than anybody thought. And this led to a pretty dramatic cycle of hype followed by massive disappointment. So the early approach was called Symbolic AI. The idea was to literally write down rules for intelligence. And, it worked okay in simple, closed systems, like a game of checkers. But in the real world, the number of possible situations, the number of choices, it's practically infinite. They called it the combinatorial explosion, and it just completely overwhelmed the computers of the day. And that frustration finally boiled over with this thing, the Light Hill Report. It was a scathing review, especially in the UK, and it basically concluded that AI had failed to live up to its own hype. It slammed the door on funding, and just like that, the bubble burst.
And that led to what we now call the first AI winter. The money just dried up. Research labs started shutting down. The whole field just went into this long, cold period of disillusionment.
Now, we did see a little comeback in the 80s with something called expert systems. They were pretty successful in very specific, narrow jobs. But they were brittle, they were super expensive, and when the specialized hardware market for them collapsed, yep, you guessed it, a second AI winter set in. But while all that symbolic, rule-based AI was struggling, there was this other idea,
A different approach, inspired not by pure logic, but by the actual wiring of the human brain, and it was quietly making a comeback from the fringes of the field.
This new way of thinking was called connectionism, and it was a total game changer. The idea wasn't to feed the machine rules anymore. Instead, you'd build these artificial neural networks and just let them learn on their own by churning through massive amounts of data.
Now, for years, progress was pretty slow. But by 2012, a few things came together. We had huge data sets from the internet, we had powerful new computer chips, and we had better algorithms. And at this huge image recognition competition that year, something happened that changed everything. The winning AI didn't just win, it totally blew the competition away. So a deep neural network called AlexNet didn't just beat the old record, it completely shattered it. It slashed the error rate by almost 11% in a single year. Now, in the world of AI research, that kind of jump is unheard of. It was a monumental leap. The game had just completely changed overnight. This was the Big Bang, the shot heard round the world for every AI researcher on the planet. AlexNet proved, once and for all, that this connectionist, data-driven approach worked. Suddenly, everything was different. The AI winter was definitively over, period. And the deep learning summer had begun.
And that brings us right up to today, to our world of massive AI models and generative art and all of it. And what's wild is that suddenly, all those deep philosophical questions that people like Aristotle and Ada Lovelace were asking, they're not hypothetical anymore. They are very real, very urgent problems we have to solve right now. Get this, more than 50 years ago, Alan Turing's own colleague, a guy named I.J. Good, he saw this moment coming. He predicted a time when an AI would get smart enough to start designing even better AIs, setting off this uncontrollable intelligence explosion. And he knew it would be the single most important event in human history. Well, guess what? We are living in the opening seconds of that intelligence explosion. And so that final, critical question, how do we get this right? That's the challenge that connects our world today all the way back to those ancient Greek philosophers. It is no longer a thought experiment. It is the defining question of our time.